Lesson 3.3, Solving Quadratic Equations Using Square Roots. You can solve quadratic equations of the form ax squared plus b squared equals c squared equals 0, where b is 0, by isolating your squared term and taking the square roots of both sides. So this is kind of a new idea, the idea of using square roots up here to solve equations. The key thing is you can't have an x and an x squared term. You can only have your x squared terms. This piece needs to go away in order for this technique to work. So that's the only scenario where you're going to be able to use square roots. Now, we've already kind of made mention to this, and we've seen it in some of our practice questions, but you have to have both a positive and a negative answer when we introduce the square root, because when we think about it, we can obtain 9 by either squaring 3, which is our typical go-to, but we could also get 9 by squaring negative 3. And this is the one we always seem to forget about when we talk about square roots up to this point, but now we need to remember that both of those are possibilities, and we've seen that because our parabola is symmetrical on the negative and positive sides for x. So when I introduce a square root in any equation, I need to note that I'm going to have both a positive possibility and a negative possibility. Those are my two options. And it's going to kind of break out almost like dealing with our two different roots when we factor. So this first question, example 1, solve. Again, solve is implying that we need to know a value for our variable. So we've got x squared equals 9. Well, the square root of x squared kind of undoes the square. The square root of 9 can be positive or negative. So because we've got this positive or negative variation of the square root of 9, we're going to end up with two answers. We could either have positive 3 or we could have negative 3. Now you'll notice the statement at the top of the page here still. It says, must always check for extraneous roots. Now that's some new language that we're not used to hearing. Okay, you must always do this. You have to check both of these values to make sure they both work. And this always needs to be happening. So our original equation isn't too bad because it's x squared equals 9. So we go back and we're like, okay, well, 3 squared equals 9. That is true. We've also got negative 3 squared equals 9. That is also true. So we're good to go. Both of these are valid answers. Okay. Remember to make sure that you put the negative inside the brackets with the 3. That whole piece is being substituted in for x. If we forget our negative, or our brackets, and we plug it in like that, this does not equal 9. This is negative 3 squared is what that means, which means it would be negative 9. And that's not what we're looking for. Okay, so the next one gets a little bit more complicated. Again, we're just going to want to isolate our x squared, take the square root of it. Those are our goals. Isolate your square, square root it to get rid of that exponent. So the first thing we do is add 1 on both sides. 2x squared equals 6. Divide by 2. We've got x squared equals 3. To get rid of that square, we're going to take the square root of both sides. So that gives me x equals positive or negative the square root of 3. You can leave your answer like this. That is okay. Totally allowed. This is what we call exact value. Especially if you plan on attending university and you're going to take like calculus when you get there, you need to be comfortable with working in exact values. So get used to seeing answers that look like this because you are not allowed a calculator in that entire course. Okay, we're not done though. We need to check our for extraneous roots, ones that don't actually work when we plug back into the equation. So check number 1, if x is positive square root 3, then I've got 2 times the root of 3 squared minus 1 equals 5. Well, that's 2 times 3 minus 1 equals 5. 6 minus 1 equals 5. That's true. I need to check my other root. And again, it is positive because that negative is inside the bracket, so a negative times a negative is a positive. And we have the same statements here, and so that is also true. So both of these are actually my answer, positive or negative the square root of 3. C becomes a little bit more complicated, because now we've got something inside our square root with our x value. So to get rid of that square, in the previous question we had to strip away everything else. We stripped away the 1, we stripped away the 2 that's multiplying. Here the square comes before that subtraction piece, and so we need to deal with it first. It's on the outside. We need to work our way in, kind of like peeling an onion. Don't start crying on me now. So the first thing we do to get rid of these brackets and that square is we're going to square root both sides. So we end up with x minus 4 equals both positive and negative square root of 12. So a couple things we can do here. We can break this into 2 pieces. We can go x minus 4 equals, and we can also simplify our radical. I'm going to work in exact values so that you get comfortable with seeing what that looks like. You can convert to a decimal, but I recommend getting comfortable with exact values as well if you plan on continuing with pre-cal and calculus. So 4 goes into 12. So just as a side note, this simplifies to 4 times 3. The square root of 4 is 2, so I'm going to go with positive 2 root 3. Then my other option is x minus 4 equals negative 2 root 3. From here, I want to isolate my variables, so I've got x equals 2 root 3 plus 4, or x equals 4 minus 2 root 3. Notice how I've written them in different orders. It doesn't matter as long as you keep that negative attached to your 2 root 3 in this scenario. And we have a positive 4 to reflect that it's moved to the other side. So those are my 2 possible answers. Now at this point you're like, I really just want to convert this to a decimal. Go ahead. I'm still going to work with exact value when I check for my extraneous roots. So check 1, I'm going to look at my positive 2 root 3 plus 4. So I'm going to plug this into my equation. Now remember that I've added in these square roots here, so they don't actually belong. So I'm filling in for x, 2 root 3 plus 4 minus 4 squared equals 12. Well, because it's just adding and subtracting, these brackets aren't actually relevant. So I can look to just collect like terms. 4 minus 4 is 0, and so I've got 2 root 3 squared equals 12. If I square that, I've got 4 and 3. I apply that square to both pieces, gives me 12. That is true. Option 2. I've got x equals 4 minus 2 root 3. So again, I plug it in for x, and because it's just adding and subtracting, I don't really need those brackets again. Minus 2 root 3 minus 4 squared equals 12. Again, minus 4 and plus 4 cancel out, so I'm left with negative 2 root 3 squared equals 12. This all negative times negative is a positive, so I still get 4 times 3 equals 12, which is still true. This little dot can represent multiplication, and we use that in order to avoid getting confused with an x versus a times, because they look pretty similar. Okay, so using that dot for multiplication. Since those both seem to work, they don't give me any funky values where things don't equal each other. Both of them are legitimate answers, so I have, again, 2 answers. What does it mean when we have 2 answers when we solve for x in a quadratic equation? If we think back to graphing and determining how many real roots, it meant we had 2 real roots, which means we're going to have 2 x-intercepts, whether we are opening upward or downward. They'll look something like that. Okay, example 2. Solve the following equations by completing the square. So when we end up with a scenario where b is not 0, all of a sudden we've got that term showing up in the middle, and we're like, oh shoot, well now we can't just take the square root, because if I take the square root of all of this, that's not going to help me, because this isn't a perfect square, this negative 10x, so that's not going to work on its own. So step 1 is I need to complete the square. So I'm going to go in and say x2 minus 10x, and I'm going to leave my plus 3 on the outside equals 0. Remember, we take half of our b value, so negative 10 divided by 2, and then we square it. So 5 squared, or negative 5 squared rather, is positive 25. So then we also need to remember that if we've added that positive 25, we need to subtract 25 out here. And so in order to be able to work with that, why did we do that? Well, we wanted a perfect square. So x minus 5 squared, and then 3 minus 25. And so we kind of imagine it's divided there. In order to be able to create that perfect square, 3 minus 25 is going to give us negative 22 equals 0. From here, we isolate our perfect square. I'm just going to move over here. So we get x minus 5 squared equals 22. Take the square root, so we've got x minus 5 equals positive or negative square root of 22. 22 can't be divided by any perfect square, so I'm not going to try and simplify it. It breaks down into 2 times 11, and that is both prime numbers, no perfect squares there. So I've got 2 options. X could either be 5 plus root 22, or x could be 5 minus root 22. Again, I'm going to need to check these values, so I'm just going to slide over here a little bit. So I've got my room. Check. 1, I'm checking my positive value, so that means I've got 5 plus root 22 squared minus 10 times 5 plus root 22 plus 3 equals 0. Continuing from there. Now, here is where you might want to convert to a decimal, because right now I'm going to have to FOIL this, even though it's 2 values, not a variable, because they can't be combined into a smaller single term. I'm going to have to square it as if it's a binomial. So I get 25 plus 10 root 22, and then plus 22, minus, and then I distribute into here, 15 minus 10 root 22 plus 3 equals 0. Well, now we need to collect like terms. I spot my 10 and 10 cancel out, so that's nice. And then I've got negative 15, but I've got 25, 22, negative 15, and positive 3. Does this work? The correct answer would be no, this wouldn't work if this was how it was going to shake down, but I didn't multiply correctly. I added 10 times 5 is not 15, it is 50. So now if I look at this, I've got it kind of figured out properly. I've got 25 plus 22 plus another 3. Well, 3 plus 22 gives me another 25. 25 plus 25 is 50. Minus 50 is 0. This works. Excellent. My positive root is okay. What about my negative one? That means I've got 5 minus root 22. From here, again, I'm going to have to FOIL this out if I don't use my calculator. So I've got 25 minus 10 root 22 plus 22 minus 50. I'm not going to make that mistake again. Minus 10 root 22. Nope, not minus. Plus. Negative times negative is a positive. Plus 3 equals 0. Again, those guys cancel out. Minus 50 plus all the rest. So that works out as well. So excellent. Both of these are my answers. And I'm done. So it seems like a lot of work. Not going to lie. It does take a few steps. But you already know how to complete the square. So we're just adding in that piece where now we need to isolate your square and solve for x. You have to do your check. You have to. Because if all of a sudden we end up with some funky numbers going on, we are possibly going to end up with things that do not work. This is also a really good habit because in our next unit, or in the following units, we're going to run into scenarios where things are not allowed. And so that's going to cause us some problems. Okay, so we're going to do the exact same thing here. We have to solve by completing the square when we are given a scenario where we've got our x squared and our b value is not 0. So, okay, remember that solve means I want to end up with this x equals statement. I want to know what my variable is. So again, I've got x squared plus 4x. I'm going to leave some space for me to complete my square, so minus 3. I'm also going to leave some space at the end so I can remember to kind of like add 0. So we take 4 and we half it and we square it. So 4 divided by 2 is 2, squared is 4. So I need to subtract 4 to make sure that I haven't actually changed anything. I split it, so I look at these first 3 terms as if they're a perfect square. So that's x plus 2 squared minus 7 equals 0. I need to get my x squared by itself. And that's as close to x squared as I'm going to get. And then I need to take the square root. So x plus 2 could equal positive or negative square root of 7. So if we look at this, we've got 2 possible options. We've got x is negative 2 plus the root of 7, or we've got x is negative 2 minus the root of 7. So we need to check for both of these. I'm checking my positive root first. I'm going to have negative 2 plus 7 squared plus 4 times negative 2 plus 7 root minus 3 equals 0. So once I've got my equation filled out, I'm going to need to, again, expand using FOIL, distribute this way. Again, if you want to use decimals, you absolutely can, but you need to get comfortable with exact values, so I strongly encourage you to keep with me here. I've got 4 minus 4 root 7 plus 7. and then not positive 8 because I've got a positive and a negative when I distribute through here. So I'm going to have negative 8 and then plus 4 root 7 minus 3 equals 0. All these guys nicely cancel out for me again. I've got 4 plus 7 is 11. 8 and 3 is also 11, but those two are negative, so that is going to cancel out and be 0. Lovely. Try the other one. So I've checked my negative root, and I see that it works as well. So both of these are valid answers. Now we're going to step it up a notch. What about when a is not 1? You use the same strategy. You're still going to complete the square. You're still going to isolate your square, and then you're going to square root and solve for your x. All the steps are still the same, we need to remember that it becomes a little bit more tricky to complete the square, and that adding 0 piece when we have a value for a as well as b. So the first thing we do is we factor out that value for a. Take out my 2, and I'm left with x squared plus 3 halves x. I'm going to leave some space. My 7 is going to hang out over here, and it's going to be all set equal to 0. From here, we take half of our b value, so that's going to be 3/4, and we're going to square it. So that is adding 9/16. Negative 2 times this is going to give us negative 9/8. So to counter that, we need to add 9/8 out here. And so again, that's where it gets tricky. If you need to do the math on the side to make sure you understand that fraction piece, do it. Absolutely, do it. From here, we're going to rewrite as a perfect square. X plus 3/4 squared. And then we're going to have to deal with this fraction. So 7, if I wanted to convert it to being over 8, that would be, I always struggle. For some reason, the multiple of 7 times 8 always doesn't stick in my head. It's going to be the same as 56 over 8. So we've got 56 plus another 9, so that's going to be 65 over 8. Okay, great. What does that mean? Well, from here, we are going to have to isolate our squared term. So I'm going to have x plus 3/4 squared equals not only negative 65 over 8, but then also divided by negative 2, which is going to turn it into positive 65 over 16. Now I want to take the square root of this. And I'm running out of room, so we're going to move over here. So I've got x plus 3/4 is equal to either positive or negative the square root of 65 over 16. Now unfortunately 65 is not a perfect square, and so we're a little bit restricted on how we're going to deal with that. And we're just going to leave it as a fraction. And I know it's ugly, but we can deal with it. So please note that when we move the 3/4 over, it becomes negative. I'm going to say that for this one, we can use our calculator. You could do it with exact values, and if you want to see that, come talk to me. You're more than welcome to. But let's use our calculators for this. In that case, I do recommend that you still plug them in as their entirety. Otherwise, you're going to get some discrepancies, and this will be like there will be some rounding problems. So you're going to want to plug it in exactly as it's written there. So we could even simplify this as -3 plus or minus the square root of 65 all over 4 since they have a common denominator. So plug these two values, the positive and the negative variation, in for your check. So if I'm plugging in the positive value, it's going to be -3 plus root 65 over 4 is equal to x. I'm going to do that on my calculator. So great. This one does work. My negative value, I'm going to plug in -3 minus the root of 65 all over 4 and as x, and this should also work. Now I'm getting a kind of funky, really tiny number. It's going to be rounded to 0. So we're going to say that it does work. We're going to follow the same process for D. I'm going to skip that one though. I'll write the answers in later so you can actually see what's going on, but you do the same thing. Complete your square, make sure you add, make sure you multiply to get that piece that you're actually adding or subtracting on the outside, and then isolate. And don't forget this negative. I want to get on to example E. So we'll see what happens here. Here we're going to factor out a half. So I'm left with x squared plus 6x. And then I'm going to have that subtracting 9 halves over here equals 0. Half and squared, 6 divided by 2 over, and then to the power of 2. So that's 3 squared is 9. But I've taken out a half, so really that's 9 halves that I've added. So I'm going to take away 9 halves out here. Moving on, that leaves me with 1/2 and then x plus 3 squared minus 18 over 2. Keep moving it around, and I've got x plus 3 squared equals positive 18 over 2, and then divided by half or multiplied by 2 to get rid of this. My 2's cancel out. So now I'm left with something that's actually more manageable. X plus 3 equals positive or negative square root of 18, which we can take out a perfect square from, because remember 18 is 9 times 2, and 9 is a perfect square. So we're left with x equals -3, don't forget that negative when you move it over, plus or minus 3 root 2. Again, I'm going to have to check these. So my positive option, x is going to be -3 plus 3 root 2. This one should be a little bit more manageable, but because we're dealing with fractions, if you want to use your calculator, I'm totally okay with that. Same thing here. If we're dealing with the negative, it's going to be x equals positive, or not positive 3. That -3 stays the same. It's now going to be not positive, but -3 root 2 here. So take a second, plug these into your calculator. Remember, this whole piece goes in for x in both scenarios, and don't forget to square it in that first term. Let's see if they both work. So here I see that both of them did work when I plugged them into my calculator. I'll come back and make another video showing you how to do this with exact values, but for our purposes to speed up this video, we're going to have that. So for this question, we're going to factor out that -1/2. So that leaves us with x squared minus 12x, and then minus 1 equals 0. So take half of 12 and square it, so that's negative 6 squared is positive 36, which means we've actually subtracted, because of this negative a half, we've subtracted 18, so we're going to add 18. When we rewrite this in perfect square form, we've got negative a half x minus 6 squared plus 17 equals 0. Manipulate it around, subtract the 17, multiply by negative 2, and we end up with x minus 6 squared equals 34. And so x minus 6 is positive or negative the square root of 34. 34 can't be simplified any further because the only factors that go into it are 2 and 17, and neither of them are perfect squares. So we're left with x equals 6 plus or minus the square root of 34. We're going to plug these both in and do our check. For a positive one, x equals 6 plus root 34. For a negative one, x equals 6 minus root 34. Again, you are more than able to do this using exact values. If you want to see what that looks like, come and talk to me. I'm going to say we can just use our calculators to speed things up, and I know that both of them do work. So again, I'm going to skip over G for our purposes today. I will make a video filling in kind of these blanks that I've left for you, but I also want you to try them on your own. Okay, so don't skip over them just because I am. Try them on your own. You know how to complete the square. You need to give it a shot on your own. See if you know how to do this. We'll look at the word problem. A defender kicks a soccer ball away from her own goal. The path of the kicked soccer ball can be approximated by the quadratic function blah, where x is the horizontal distance. Okay, so if we're looking at it, the ball travels like this, x is here, and hx is our output. It's the height in meters. So again, we're talking in meters, so don't forget when we write our answers that we actually are dealing with units. So, can you determine the distance the soccer ball is from the goal line by solving the corresponding equation? How far is the goal line when it is kicked? Okay, so the goal is over here, is essentially what we're talking about. Away from her goal. Determine. Okay, so we're assuming that she's kicking from the goal line. So we're going to solve this by factoring out our 0.06 to start with. So -0.06 x squared. If we divided this by negative 0.06, we've got 3.168 divided by, we get negative 52.8. Now you're going to be wanting to use your calculators for sure on this question. Minus 35.434, and then equals 0. We're going to half and square it. So that's going to be positive 696.96, but really we've just added negative 0.06 of that. So we're going to counter it by adding 41.8176 on the outside. From here, we write our perfect square, negative 0.06 x minus 26.4, because that was half of 52.8 squared, minus, and we're going to combine that. These two values here, 4.34, gives us positive 6.4776 equals 0. We're going to move it around. X minus 26.4 squared is going to be negative 6.4776 divided by 0.06. Take the square root of that. X minus 26.4 is going to be positive or negative. And then we're going to take the square root of 107.96. That's going to give me 10.390. And I'm just going to cut it off there because I get to a 0, so it kind of gives me a nice place to end. And then I've got x equals 26.4 plus or minus 10.390. So we're looking at when the ball is kicked, how far is it from the goal? So do you think it's farther away or closer if she's defending her net? Odds are she's going to try and kick the ball away from her own net. She doesn't want to kick it towards her own net in soccer. So we're going to go with the smaller value. So we're not going to go with the addition. We're going to go with the subtraction. Okay, and so my final answer is going to be x equals 26.4 minus 10.39, which is going to be 16.01. So we're going to just say 16 meters to start with. So that's how far the goal line is when the ball is kicked. How far does the ball travel before it hits the ground? Well, we started at 16. It finishes at the addition. So x equals 26.4 plus 10.39, which is 36.8 meters. So the difference between it, the distance traveled, is going to be 36.8 minus 16, which gives us 20.8 meters traveled. So there's lots of practice questions. If you didn't do them, if you skipped over them, go back and look at G and D from above. Make sure you try them. I will be posting a video that shows those examples. Okay, there's lots of questions in the textbook, there's lots of questions following, so make sure you are practicing this a lot because this is probably one of the most complex things that we're going to be doing.